This is lesson 4.2, patterns and linear functions. Making it a YouTube video so then you can go back and watch it also again if you need to at your own pace. Pause it when you need to, and however many times you need to watch it, whatever you need to do. All right, so first of all, in a relationship between variables is what varies. The dependent variable changes in response to the independent variable, right? Which makes sense. The dependent depends on the independent. So the values of the independent variable are the inputs. So what you put into the problem are the independent variables, right? What goes in is the independent, the input. The values of the dependent variable are called outputs. So what you get out of the problem are the outputs, and those are the dependent variables. So we're going to look at a situation here. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. All right, so let's start with the table. So making the table, the independent is what you start with. So we start with our number of rectangles. I'm just going to abbreviate, number of rectangles. And based on the number of rectangles, we get our output, our dependent, which would be our perimeter. So first we start with one rectangle, then we have two rectangles, three rectangles, four rectangles. So those are our inputs. Then to find the perimeter, what we get based on that, the output, we would add up the sides. So we'd have 6 plus 1 plus 6 plus 1 gives us one rectangle has a perimeter of 14. Two rectangles, we have 6 plus 1 plus 1 plus 6 plus 1 plus 1, which gives us 16. Three rectangles, 6 plus 1 plus 1 plus 1 plus 6 plus 1 plus 1 plus 1. We have a perimeter of 18. Four rectangles, we have 6 plus 1, 1, 1, 1, 6, 1, 1, 1, 1. So that would be a perimeter of 20. So there we have represented it with a table. All right, so we'll do an equation in words. So in our graph here, I can see I have a graph here. So if the input is 1, the output is 14. So that's just like having an ordered pair of 114, right? I can graph that 114. I'd go right 1, up 14. Boom. And then I have 2 16. So that's like going right 2 and up 16. And so on. So we have 2 16, then we have 3 18, and then we have 4 20. So there you can see I have graphed my points. Now, if I'm going to connect those, you can see when you would connect them that they actually form a line. So that's one way to tell that this is linear, right? This is a linear situation because it creates a line in the graph. We can tell looking at our table that it's linear because when you look at your dependents from 14 to 16, you add 2. From 16 to 18, you add 2. From 18 to 20, you add 2. So when you have a table, if you have a constant, meaning the same increase in your dependent, then you know it's linear, right? If you graph it and it makes a line, you know it's linear. So we did our graph. So then when we have to come and make our equation, since we know it's linear, looking at either the graph or the table, we know that it's going to be in the form y equals mx plus b, right? That's a linear equation. All right, so we go and we fill that in. We'd have y equals something x plus b. Well, we can figure this out a couple different ways. The easiest way, I think, is b is your constant, right? It doesn't variable. It's constant. So looking from each rectangle pattern to the next, I can see what's constant. What keeps staying the same is we have 6 and we have 6. And the next one, we have a double 6. And the next one, we have a double 6. And the next one, we have a double 6. So what is constant, what is always staying the same is a double 6, which would be 12, right? 6 and 6 is 12. Then what does change, so what changes is the first one we had 1 and 1, right? So we just had 2. And the second one we added another 1 and 1, so we added another 2. Then we added another 2. Then we added another 2. So what keeps happening, what keeps changing is it keeps going up by 2. So this number, this constant on the end is what always stays the same, right? What is your constant? What is staying the same? In each pattern, it always had a double 6. Every single time there's a double 6, so there's always 12. Then what you keep adding, the same from each one to the next one, is you kept adding 2 because you'd add a 1 on top and a bottom. So you'd add 1 and 1, which is 2. You'd add 2. You add 2. You can look at your table here and see you keep adding 2. So the equation would be y equals 2x plus 12. And then you could describe it. You could plug it in and see. If you plug in 1, 2 times 1 is 2 plus 12 is 14, like the first pair says. When you plug in 2, 2 times 2 is 4. 4 plus 12 is 16. So that one works. Plug in 3. 2 times 3 is 6 plus 12 is 18. 2 times 4 is 8 plus 12 is 20. So you can see that it works for all of those. And then I'm not going to write out the words. I just describe the words, and that's our first one. So it's linear, I can tell, because the table, the dependents always go up by a constant, and when we make a graph, it makes a line. It's linear. So our next one here, same concept. We can see we've got triangles, though, this time. So our independent, what we're starting with is our number of triangles. And based on our number of triangles, we're going to have our perimeter. So we have 1 triangle, 2 triangle, 3 triangles, 4 triangles. So 1 triangle, our perimeter, we have 3 plus 3 plus 4, which is 10. 2 triangles, 3 plus 4 plus 3 plus 4 is 14. 3 triangles, 3, 4, 3, 4, 4 would be 18. And then 4 triangles, 3, 4, 4, 3, 4, 4 would be 22. So there's our table, right? Again, I could graph these points. Let's see, I've got 1, 10. So write 1 up 10, 2, 4, 6, 8, 10. Write 2 up 14. Write 3 up 18. And then 4 is 22. We're a little bit off. But again, you can see that if you were to connect these points, they make a line. It is linear. If you look at your table over here, you can tell it's linear because from 10 to 14, you add 4. From 14 to 18, you add 4. From 18 to 22, you add 4. So our equation, y equals what x plus b? We can look and see what is constant. So what I see as constant this time is I always have a 3 and a 3. Here I've got a double 3. Here I've got a double 3. The double 3 remains constant in every single situation. So they always have a double 3. So 2 3s would be 6. That's what's staying constant. And then I can see what keeps getting added. Here I had 1 4. Now I've got 2 4s. Next one I have 3 4s, and then I have 4 4s. So what keeps changing is it always goes up by 4. I keep adding a 4. So it would be 4x plus 6. Again, I can see that I can get that 4 also here from my table. What I keep adding is 4. What stays constant from 1 to 1 is the 6. You have a double 3. Again, you can plug it in and see that that does work. If you plug in 1, 4 times 1 is 4 plus 6 is 10. Boom. If you plug in 2, 4 times 2 is 8 plus 6 is 14. Boom. Plug in 3, 4 times 3 is 12 plus 6 is 18. Plug in 4. 4 times 4 is 16 plus 6 is 22. So it works for all those. So again, you can see that this is linear because the equation is in the form y equals mx plus b. The table has a constant increase, always adding by the same amount. And when you graph the points, they make a line. All right, so we keep saying this word function. So what a function is, it's a relationship that pairs each input value with exactly one output value. So every x that you put in, you can only get one answer. You can only get one y out. You put one number into the function and one number comes back out of the function. So then linear functions are ones that make a line. So we're going to learn about all kinds of functions this year. Right now, we're just focusing on linear functions that make lines. So here, the table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So we already have our table right here. So we can see, looking at our table, if you take no pictures, you have 512 megabytes. If you take one picture, you have 509. Two pictures, 506. 3 pictures, 503. So I can see going from 512 to 509, I actually go down 3. From 509 to 506, I go down 3. From 506 to 503, I go down 3. So remember, subtracting is the same as adding a negative. So what I keep adding each time is -3. So this is linear. This is a linear situation. If I go and graph it, I'm going to have to change here a little bit. I've got 0, 5, 12. So maybe I'll do like count by 50s, 50, 100, 150, 2, 250. Maybe I'll just count by 100. So this will be 100, 200, 300, 400, 500. So we've got 0, 5, 12. Then we have 0, 509, then 0, 506, and then 503. Actually, let me do this. Do you remember back in middle school or how you would do a break? So let's do a break and then start counting by 500. And then we'll count by 1. So here's our break symbol. So then we've got 500, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's 0, 5, 12. Then 1, 509. Then we've got 2, 506, 3, 503. So again, I can see it's still making a line. The only difference this time is the line is decreasing. I can tell in my table here that it's linear because you're always adding a constant amount. You're adding -3. It's the same thing as subtracting 3. Adding a negative is the same as subtracting. So then I know it's linear. I know it's y equals mx plus b. So what I'm always adding each time is -3. So it's -3x plus, I have to figure out what the constant is this time, right? It's not as easy to tell, except you just have to do a different approach. So your constant is what you have at the beginning before you start. Well, before you start, you're at 0. So when I'm at 0, I have 512. So my constant here is 512. So this amount is also what you have when x is 0. So when x is 0, our constant, our y is 512. So then when you substitute in, when you plug in 0, -3 times 0 is 0, plus 512 is 512. When you plug in 1, -3 times 1 is -3, plus 512 is 509. When you plug in 2, -3 times 2 is -6, plus 512 is 506. It's going to work every single time. So linear creates a line. So the equation is y equals mx plus b, and your graph would always make a line. Here our table is just going the other way. So I can see here from 8 to 10, I add 2. From 10 to 12, I'm adding 2. From 12 to 14, I'm adding 2. So I can see that this is linear because the difference is always constant. I'm always adding the same amount there in my output. When I go to make my graph, I have 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. Then I go to 1, 10, 2, 12, 3, 14. So again, I can see when I have a graph, that graph makes a line. So those are two ways you can tell if something is linear, right? On your table, the output, the y values, you're always going to add the same amount from term to term, and your graph is always going to make a line. Since it's linear, it's always y equals mx plus b, right? Your m is what you add every single time. So here we can see that we keep adding 2. So it's 2x plus your b here is your constant. What is y when x is 0? Well, when x is 0, I can see that y is 8. So this would be 8. So then I can plug in and see how that works. If I plug in 0, 2 times 0 is 0, plus 8 is 8. Works. If I plug in 1, 2 times 1 is 2, plus 8 is 10. Plug in 2, 2 times 2 is 4, plus 8 is 12, and so on. Linear functions have a constant increase, and they make a line.